Welcome back. Today our topic is simple linear equations. Now, let us first understand, what is an equation? An equation is a mathematical statement with an equal to symbol between two expressions that have equal value. Example, 2x plus 5 equals 10. Here, the equality sign indicates that the value of the expression on the LHS is equal to the value of the expression on the RHS. That is, LHS is equal to RHS. Now, if there is other sign other than equality sign between LHS and RHS, it is not an equation. Example. This is not an equation, it simply says the value of 2x plus 4 is greater than 8. This also is not an equation, it simply says the value of 2x plus 4 is lesser than 8. Balancing of an equation. To balance an equation, there are 4 rules which must be followed. Rule 1, any number added to one side must be added to the other side. Example, x minus 2 equals 5. Now, if we add 2 on both sides, we can easily isolate x and find its value. So, x minus 2 plus 2 equals 5 plus 2. Therefore, x equals 7. Rule 2, any number subtracted from one side of an equation must be subtracted from the other side too. Example, x plus 2 equals 5. Now, if we subtract 2 from both sides, we can easily isolate x and find its value. So, x plus 2 minus 2 equals 5 minus 2. Therefore, x equals 3. Rule 3, we can multiply both sides of an equation by the same non-zero number. Example, x by 2 equals 4. Now, if we multiply both sides by 2, we can easily isolate x and find its value. So, x by 2 into 2 equals 4 into 2. Therefore, x equals 8. Rule 4, we can divide both sides of an equation by the same non-zero number. Example, 4x equals 48. Now, if we divide both sides by 4, we can easily isolate x and find its value. So, 4x divided by 4 equals 48 divided by 4. Therefore, x equals 12. So, when solving for an unknown variable, balancing ensures that the variable is isolated, while the equation remains true. Now, root of an equation. In mathematics, the root of an equation refers to the value or values of the variable that make the equation true, typically resulting in a zero value when substituted back into the equation. An equation can have a single root, multiple roots, or no roots at all. Example, solve 3x plus 7 equals 22. Let's call 3x plus 7 equals 22 as equation 1. Now, we try to isolate x from the equation. First, let's subtract 7 from both sides of equation 1. 3x plus 7 minus 7 equals 22 minus 7. We get 3x equals 15, let's call this as equation 2. Divide both sides of equation 2 by 3. 3x divided by 3 equals 15 divided by 3. Therefore, x equals 5. If we substitute the value of x in equation 1, we get 22 equals 22. Therefore, value of variable x equals 5 makes the equation true. Hence, 5 is the root of the equation. Solution of a linear equation. Trial and error method. Here, we substitute various values for an unknown value in an equation, and find the particular value, for which the value of the LHS becomes equal to the value of the RHS in the equation. Example, solve 7 minus x equals 3. Consider the table. In the first column we have value of x. In the second column we have LHS of the given equation, 7 minus x. In the third column we have RHS of the equation, 3. And in the fourth column we have conclusion. Now, if we substitute the value of x as 1, we get LHS as 7 minus 1 equals 6. RHS does not have any variable, so the value remains the same, that is 3. Conclusion is, LHS is not equal to RHS, since 6 is not equal to 3. We execute the same process sequentially, substituting for the value of x. Now, for the value of x equals to 4, LHS equals RHS. Therefore, x equals to 4 is the solution of the equation. Systematic method. As we have seen, the trial and error method becomes lengthy and inconvenient in solving an equation. So we use systematic method to find the solution. Example, solve 2 into m plus 6 equals 3 into m minus 10. So, 2m plus 12 equals 3m minus 30, let's call this as equation 1. Now, we transpose minus 30 to LHS and 2m to RHS. Remember, changing sides is called transposing. While transposing a number, we change its sign. So, 12 plus 30 equals 3m minus 2m. m equals 42. Now, let us check. Substituting the value of m equals 42 in LHS and RHS of equation 1, we get LHS equals 2m plus 12 equals 84 plus 12 equals 96. RHS equals 3m minus 30 equals 126 minus 30 equals 96. Therefore, LHS equals RHS. Example, solve the equation and check. X minus 5 by 7 minus 8 equals 2x plus 4 by 5. First, let us simplify this equation. So we have 5x minus 305 equals 14x plus 28. Let's call this as equation 1. Transposing 5x to RHS and 28 to LHS. We get minus 333 equals 9x. X equals minus 37. Now, let us check. Substituting the value of x equals minus 37 in LHS and RHS of equation 1, we get LHS equals 5x minus 305 equals minus 185 minus 305 equals minus 490. RHS equals 14x plus 28 equals minus 518 plus 28 equals minus 490. Therefore, LHS equals RHS. Simple application of a linear equation. The following steps should be taken to solve a word problem of linear equation. Read the problem carefully, and note down what is given and what is required. Analyze and understand the relationship between different quantities given. Represent the required quantity by a variable, say x, y, z, etc. State the relationship as an algebraic equation. Solve the equation for the unknown quantity. Example. In a family, the consumption of cereals and vegetables is in the ratio 5:2. If the total quantity is 35 kilograms, find the consumption of each. Step 1. Given ratio of consumption of cereals and vegetables equals 5:2. Total quantity of cereals and vegetables equals 35 kilograms. We have to find consumption of cereals and consumption of vegetables. Step 2. Let us represent consumption of cereals by variable x and consumption of vegetables by variable y. Step 3. We have x by y equals 5/2. Let's call this equation 1. Also, total quantity of cereals and vegetables, that is, x plus y equals 35 kilograms. Let's call this as equation 2. From equation 1, x by y equals 5/2. X equals 5y by 2. Now, substituting value of x in equation 2, we get 5y plus 2y equals 2 into 35. Y equals 10 kilograms. So, x equals 5y by 2 equals 5 into 10 by 2. X equals 25 kilograms. Therefore, consumption of cereals equals x equals 25 kilograms. Consumption of vegetables equals y equals 10 kilograms. Divide 38 in two parts, such that one part is 18 more than the other. Find the values of the two parts. Given, divide 38 in two parts. One part is 18 more than the other. Let us represent first part by variable x. Second part by variable y. Now, x plus y equals 38. Let's call this as equation 1. Also, one part is 18 more than the other part. Let's call this as equation 2. Here you can assume one part as either x or y, we assume it as y. Substituting the value of y in equation 1. X plus 18 equals 38. X equals 10. Also from equation 2, y equals x plus 18. Therefore, y equals 28. A number is 3 times another number. When the larger number is subtracted from 100, the result is 30 more than the smaller number subtracted from 50. Find the numbers. It is clear that there are 2 numbers involved here. Let us represent first number with variable x and second number with variable y. Given is x equals 3y, let's call this as equation 1. Here, we can observe x is the larger number compared to y. And larger number is subtracted from 100. That is, 100 minus x. And result is 30 more than the smaller number subtracted from 50. That is, 30 plus 50 minus y. Therefore, 100 minus x equals 30 plus 50 minus y. From equation 1, x equals 3y. So, 100 minus 3y equals 30 plus 50 minus y. Transposing, we get minus 2y equals minus 20. Y equals 10. And x equals 3y. Therefore, x equals 30. Miss Angami is 5 years old. Her father's age is 31 years. After how many years will her father's age be 3 times of her age? Given, Miss Angami's age equals 5 years. Her father's age equals 31 years. Now, after x years, father's age will be 31 plus x. After x years, Miss Angami's age will be 5 plus x. Given, after x years, father's age equals 3 times Miss Angami's age. So, 31 plus x equals 3 into 5 plus x. 2x equals 16. X equals 8 years. Therefore, after x equals 8 years, father's age will be 3 times Miss Angami's age. This ends our topic on simple linear equations. Thanks for watching. Check out our other videos and subscribe to our YouTube channel. Until then, stay safe and live healthy.